Welcome everyone. Introductions to reality and Six Sigma. This is the topic of presentations for today's discussion. So we'll understand what is reliability and what exactly is meant by Six Sigma. Now, the development of Six Sigma was way back in 1980s, launched by Motorola. General Electric initiated the implementation of Six Sigma in mid 1990s, approximately 10-15 years later, after Motorola organization as of today, in fact, in all industries have applied Six Sigmas in recent times. Six Sigmas has actually replaced TQM, Total Quality Management, BPR, Business Process Reengineering, as the key strategies for quality improvement. Kaizen was the thing. So these are the latest technology, the latest concept, the latest philosophy is all about being Six Sigma oriented as far as defects per million is concerned. So what is Six Sigma? Let us understand the definition. Here is Sigma. It's a standard deviation or the measure of variability, as in what are the variation that can be expected from the norms. Six Sigma is a quality improvement philosophy that focuses on eliminating defects through improvement in the reduction of variation in a process per se. So we are eliminating defects, and that is what Six Sigma is all about. It. Remember, we are talking about standard deviation thereby. Defect, a measurable outcome that is not acceptable within the limits, as they say. So a measurable outcome that is not within the acceptable limits. If we are defining that as to be the defect, as a defect. So Six Sigma is all about conforming to error-free outcomes, error-free processes, error-free products, error-free services. So total quality management vis-a-vis Six Sigma. Let us understand what is total quality management and how does it relate to Six Sigma. A management philosophy of quality improvement is total quality management. But Six Sigma is a philosophy that focuses nothing but only on defect reduction and cost reduction. So look at the different aspect altogether. Total quality management encourages involvement of every employee, but Six Sigma relies on a selected group of highly trained employees. Why are they looking at a select group? Because they are interested only in finding the defects, what is going wrong, and they are interested only to remove the anomalies or check and balances the anomaly thereby. Senior management provides direct support in cases of total quality management, but senior management is held accountable for the result in Six Sigma, and that is what makes the thing so different. The key success factor for Six Sigma is committed leadership from the top management, and they will espouse for it because this means more profitability, less of reduction, less of cost wastages, less of more of cost reduction, and so on and so forth. Integration with the existing initiative, business strategy, and performance measurement, thereby process thinking. We're talking about disciplined customers, market intelligence gathering, a bottom line orientation, and a continuous reinforcement and rewards. This is what we are looking forward to in the form of trainings per se. Six Sigma metrics. How do we adhere to it? How do we perform? So basically, we are trying to measure defect rates, defects per unit, or DPU, as the case might be. So number of defects discovered to be divided by the number of unit produced. So if you have 100 products produced unit and there are 10 defects, it is going beyond the limits of Six Sigma. So that means approximately 90% of the products are perfect, but 10% of the products are defective. Defects per million opportunities is what the measurement criteria is all about it. So it's not about 100, it's not about 1,000, it's not about 100,000, it is about 1 million. And if we have 10 defects, it is perfectly understandable or acceptable. So number of defects discovered divided by the opportunities for errors into 1 million is how we are going to calculate the defects per million opportunities, or DPMO. Now we are talking about USN and LSN, that is upper specification limit and a lower specification limit, beyond which it is not acceptable. You should be within the premises of upper and lower specification limit thereby. So we are talking about capability index is CP, wherein USL minus LSL divided by Six Sigma is what the process is all about it. The capability index. I will elaborate it with an example. For example, a student is applying for a loan application, right? So standard working days are 26 days. So 26 days is the standard working days in a month? Probably yes. So what will be the specification in limited? It should be around 20 to 32 days of working days that comes around here. So if within 26 days, if it has been accepted or the loan has been processed, when I say loan has been processed, the outcome is very much known. It might be positive, it might be negative, but the outcome is there. So specification limit has to be from 20 to 32 working days. Earliest accepted time will be 20 and latest accepted time would be 32, beyond which it is not acceptable at all. And there are the Six Sigma been 2 working days. So 32 minus 20 is 12 and 6 into sigma being 2 working days, right? It requires 2 working days to work process the loan around here. So 6 into 2 is 12, that is 1. It is within the limit of 3 sigma. That is perfectly acceptable. The capability index says so. So capabilities index and defect per million orders. If it is 1, it is 2,700. If it is 1.3, it is 63. If it is 1.5, it is 6.8. If it is capability index is 2, it is 0.002, as the case might be. The defects per million will be elaborated out here. So which is most important, which is acceptable and which is not. If you look into it, we need to understand we should be going from 2 or beyond that. Estimating processes capability index for a sample, let's say the capability index forms, let us have an X bar or average outcome from a sample and the standard deviation from a sample. Now, if you look into it, the capability index at the minimum of level, the upper specification limit and the average outcome of a sample divided by 3 sigma, or X bar minus lower standard, because X bar would be on an average on the middle side, upper would be on the upper end, and the lowest specification limit on the lower end. So X bar divided by or subtracted by lower specification limit divided by 3S is what we are going to go around it. So example is 25 days, S being 3 days. So minimum is 32 minus 25 days, if I say so, 3 into 3. 3 days being the specification limit, as the case might be a 25 into 3, it will be a minimum of 0.55 days as the capability index can be calculated. Again, very simple, please understand. Upper limit, let me tell it with you with a pen, if I may say so. Now, if you have an upper limit, this is an upper limit, this is a lower limit, right? Lower specification limit, and this is what I say is the average bars that comes around here. Now, if you have to say so, if you have to understand this thing, now USL is upper and low SL is lower specification limit, and this is X bar. So check with it, USL minus X bar divided by 3 times the standard deviation. In this case, it might be 3 because we are talking about both the upper and the limit things. So the standard deviation cannot, I repeat, it cannot go this way and that way. Probably it has to be somewhere down the corner, absolutely on a scale of this and this, it can come around it. So please understand these things, which is very important. So you have an upper exit limits that comes around. We are talking about X upper specification limit deducted by X bar, which is bottom part, divided by 3 times the standard deviation, multiplied by X bar becomes a higher end, subtracted by the lower specification limit and divided by the 3S as the standard deviation. So if we have to understand the capability index as a mean shifting procedures, that is what we are looking for it. This is what the mean shifting procedures is all about it. Here in comes the capability index, ensuring that the process variation itself is half the design. The tolerance level being at 2, while allowing the mean to shift by 1.5 times the standard deviation. This is what will be the target is all about here. And that works in favor of the company thereby. So K sigma levels of quality level at 0, there are 6 sigmas of 0.002, if I say so, quality level. At 0.25, it 0.063. At 2 sigma, it is hugely 32, and that is not acceptable. So we need to understand at 3 sigma, 2.5 sigma, what are 6 sigma result at 3.4 defects per million opportunities, as the case might be. This is what we need to understand every now and then. This is what will be the case scenarios per se. This is what we are looking at into at $3.4 million defects per million, and that is at 1.5 sigma, both on the positive side and the negative side. We are coming to a balance about it. So, General Electric Six Sigma advices of problem solvers in DMAIC or wallet DMAIC is define the problem, measure the problem, analyze the problem, improve upon the solution, and control it. Is the DMAIC that comes around it. Define, measure, analyze, improve, and control is what we all are gathered to go around here. Let us understand the DMAIC one by one. DMAIC, the definition is to identify the customers, identify their priorities. We are talking about identifying their problems, the business objectives. Select Six Sigma project teams. Define critical to qualities as the characteristic that a customer considers to have the most impact on the quality, as the case might be. We are looking forward to it. We will be talking about the measures. We have stated the definition part about the problems of the customer, the priorities of the customer, the processes, the outcome that we are looking into it. Now let us go with the M aspect, as in measure, as to determine how to measure the process. Remember, if you can determine the measurement process altogether, it will becomes very easy for you to manage it. Anything that can be measured can be managed. So identify key internal processes that influences the CTQ, the quality, measures the defect rate currently generated relative to this process altogether. This is very essential. Understand the defective rates at at that level. We talk about analyzing. Now, once you have understand, define the problem, you have tried to measure that process. Now is the time where you have to analyze the likely causes of the defect. What is it that is not working in your favor? Identify the key factors that are most likely to create the process variation, thereby we are improving upon it. Identify means to remove causes of defect, confirm the key variables, quantify the effect on CTQs, identify maximum acceptable range for the key variables, and the system to measure the definitions of the variable, thereby modify the process to stay within the acceptable ranges as on when on basis. So we need to understand this thoroughly. We need to modify the process to stay within the acceptable ranges, as the case might come across with it. We come to the last step, is all about control. Determine how to maintain that improvement. If we have improved upon it, we should make that improvement sustainable and repeatable. Probably it is advised that we adhere to it. So put in all the tools in place to ensure that the key variables remain with the maximum acceptable ranges under the modified process, under the new process that we are looking into it. Try to establish the norms around it and ensure that this thing will be repeated time and again. So tools for Six Sigma or perhaps for quality improvement is elementary and advanced statistics, because that gives you a good quantum of effect as to what you are doing right and what can be improved upon it. The product design, the reliability analysis, the measurement, the process control, the process improvement, implementation and teamwork, customer service and feedback, if I may say so, and the lean thinking possibility. These are things that needs to be attained time and again wherever possible. You need to understand this. Yes, these are the tools that has to be made pertinent. So organization for Six Sigma, there are project champions, let's say in terms of project selection, management, knowledge sharing, and so on and so forth. Why knowledge sharing is important? Because this will enable the organization employees to know what are the best practices and how to adhere with it. So knowledge sharing is one of the major requirements for being a project champion. We are talking about other belts in terms of master black belt, in terms of coaches, technical leaders, instructors. We talk about black belts in terms of project teams and team leaders, green belts in terms of project members, temporary members, and so on and so forth. Now, what are these members? What are these belts we are talking about? These are the essential core group of people who are going to strive for Six Sigma's excellence in the organization, who are going to ensure that the process is in right places, thereby. With this, I come to the end of this presentation. Thank you for understanding what has been meant by reliability, what is meant by Six Sigma. I just try to give you an eye-opener introduction to Six Sigma and reliability thereof. Thank you once again.